Hello, everyone. This video is going to walk through 3 of the examples that were in our handout that we did not get to during class. And I wanted to walk through these examples from the textbook just to give a little bit of additional context and how I go about breaking apart these problems. So we've got clay sprays, and they produce high-quality aerosol sprays for hospitals and clinics. And currently they have the following financial information here. So we see that they are selling items for $6 per unit, and they have variable cost of $3 per unit, plus $2.8 million in overhead, which if you average that into this cost, right? $3 per unit, and at 1,000,000 units here, this would be $280 per unit. They're basically costing $580 per unit by the time they distribute all of their overhead costs out across their units, which means they're not making very much money per unit. So this low volume, having a low volume like this that's eating up your overhead when you have excess capacity, means that the best way for you to make more money is just try to find ways to expand usage of that existing capacity, so you can distribute those fixed costs over a larger number of units. So the company decides that they want to try and look for another company that they can merge with or purchase, so that they could expand the utilization of their manufacturing facilities and distribute those overhead costs over a larger number of units. So there's a competing product company called Coronas that makes lower end items but can use the same type of manufacturing equipment. And just like clay, they are currently selling 1 million cans of their item, right? So when we think about costs here, right? So the total cost for an item per unit is equal to the variable cost per unit plus the fixed cost per unit. And in this case, what we would need to do then is we would need to try to come up with a greater number of units that we can divide these fixed costs over here, right? So without this, right, what we're looking at, I know I said 580 here, but the total costs that we have here are $5.8 million for this 1 million units. If we divide that out, so we have a variable cost per unit of $3, and then the fixed cost per unit is going to be equal to that 2.8 million divided by the million units, right? So total cost per unit gets us to that 580. So I just wanted to walk through that, right? You could all see it on the left there, but I wanted to walk through this from a formula standpoint also, right? Now, if we take this and we double the number of units here, right? We're still going to have the $3 variable cost per unit, but now we can take that 2.8 million and divide it by 2 million units that are created or manufactured. So then suddenly when we add those together, we're coming up with only 440 per unit, right? So now if we're selling, $2 million per unit here, if we're selling them all at the $6 per unit, potentially, let's see, hold on. Clay Managers predicts, so the same $3 per can, we do not add any incremental profits to clay. So we'll just assume that those ones are break even, but that means that for our original million cans that we have out there, we would still be having $6 million in revenue and $3 million in variable costs. But instead of allocating $2.8 million in costs to these, we would only end up allocating 1.4 million out to those, because half of it would get allocated over to the Coronas side. Okay. So for those original million units, then if we do this math, then we would be making 1.6 million instead of $200,000 here. So it would be effective in making more money from the standpoint that even if all we did was break even on those Coronas ones by allocating out those fixed costs elsewhere and splitting them off, we would end up increasing our overall net income by 1.4 million, basically. Okay, let's see. So does our profitability improve? And I would say yes. Well, let's see. Hold on a second here. They're saying in the text here that it would stay the same. Ah, yes, and getting ahead of myself a little bit here. So they are selling the Coronas products for only $3 a can, which is the variable cost. So in that case, we wouldn't be able to allocate any fixed costs over to them. So that would be the sticking point there that you'd want to look for, right? Like, are we able to actually allocate those fixed costs over to the new units? If they were equivalent and they were being sold at the same price that we're currently selling our goods for, which is $6 per unit, we could allocate that price over. But if they're only paying between units $3 per can, then the clay side of the company is not going to make any money because they're basically getting their variable or they're only getting reimbursed for the variable costs and not for the fixed costs. So looking at this with Coronas, it would not necessarily be profitable for them to make that acquisition. But if they were to have another company that was paying more than the variable costs, again, this gets back to that transfer pricing problem, right? Like, so if we have these separate units, if they're only paying it for it at cost and we can't assign any of our fixed costs over to it, then it doesn't necessarily benefit us to do so. Now, if we did, however, allocate this, so in part C, they say, let's see here. So any inconsistencies between our answers in part A and B, let's see. So if we were calculating our overhead rate based on this 440, then that would be beneficial for us. But if we run this based on this problem here, I'm going to walk through this profit part. They show this in the text, but if we do this with clay alone, right, we had 6 million. With net income of 200,000. And let me just put my commas in there. So if we do Coronas alone, right? We end up with basically zero profit. And so if we combine them just on this basis, right? We still end up with the same 200,000. Now, technically though, like we really should be shifting some of that cost over to those if we are creating those for them. If we're making those on their behalf, they should be responsible for part of the costs. So that's where the inconsistency comes in here that they're asking about profitability. If we just do this, if these two companies just operate the way they always have, only now we're making Coronas' stuff for them, then there's no shifting of those fixed costs. So if, and then also what we end up with here too, by the way, right? So now we've got $9 million for 2 million units. So the average price that we're getting here let me put in my format here with a couple decimal points. So we're really only getting 450, like in the combined company, 450 per unit here because we're selling some of them at wholesale. Um, and then our variable cost is still going to be the 3 million per unit. But in terms of total expenses here, right? Um, so what did I do here? Divided by 2 million. Um, so we are still technically making money, right? But we're not making any additional money here. Now, ideally, you would, as an internal cost, um, be shifting some of those fixed costs over, which would then decrease and make this more profitable. But still, if you're still only getting these exact prices, then you'd end up losing money on the Corona side. So that would have to be accompanied by getting a better price for those, or attempting to sell more units at the retail price instead. Um, so complicated problem, lots of different things going on there as far as how that would work out. Now, if they bought another company that was not selling them for, the same price that they would need to um, get just to cover their variable costs. So if they could get a higher price than that with whatever company they combined, then they could make that company just break even and shift some of those fixed costs over and would show more profitability. Now, if they were to do this without increasing that price, though, right? Then Coronis would suddenly stop showing a profit here. Actually, here, let's use my auto sum button. There we go. Um, and let's drag that one over. We'd be looking at the exact same $200,000 here, right? Okay. Looking at this next problem here. We have New View Company, and I'm just going to do a quick little drawing here, right? So they say here we've got each batch of M68JJ, and that costs $22,000, right? And that splits off into V7 and AC. And for V7, we get 300 pounds. And for AC, we get 400 pounds. And so this right here, this ends up being a joint cost, right? So before the cost to produce this is the $22,000. So these can sell for $35. And these can sell for $25. All right, I'm just going to note it. There, we've got our revenues. Okay, now, and then those products can be processed further. So for $2,000, we can convert these 300 pounds into 240 pounds of V7HX. And that, let's see, so $2,000 right there, okay? I'm going to put that in parentheses here, and I'm going to do that here also. And that gets us 240 pounds. I feel on these process ones, sometimes it's handy to write this out like this so that you can see where everything goes. Okay, and then we could take this 400 pounds of AC and we could convert that into AC92, a further refined product. And that costs us $1,500 here, okay? All right. And then these can be sold for $50, and these can be sold for $45. All right. Now, the $22,000 batch cost is allocated to the two intermediate products using pounds. Okay. So basically, if we've got 700 pounds here, right? We divide out that 22,000 pounds into the 700 pounds. That gets us a cost here of 31.43, we'll say. We'll round that off. So, and down here, we're going to get 400 times that. So if we highlight those, that gets us, well, we're slightly over $22,001. Okay. So let's see here. Let me put this to the 0.428. All right. So basically this is the one that needs to round. So 12,571 and 94.29. Okay, that gets us to our exact $22,000. All right, now let's see. So they're asking us then prepare a financial statement. If they are sold and not processed further, calculate the profit per batch. Okay, so we're going to put here V7 and AC. We're going to have the revenue per unit, the number of pounds, and total revenue. The joint costs here, and get the profit. Okay. So revenue per unit we said was 35 and 25. And then the number of pounds is 300 and 400. So multiplying that out. Oh my gosh, I can't type. Gets us $10,500 there. And then in terms of joint costs, we already calculated that out. So that gets us then to 1,071 and 2,571. So total there of loss of $1,500. All right, so that's not looking ideal. So what we want to do then here is try to say, all right, we probably should process some of these further to see what this looks like. All right, now let's see what happens for each of these if we were to process them further. All right, so I'm just going to take this format right here and copy it. Oops, copy it down. And then adjust this for the revised items here. Okay, so HX. So that's going to be $50 per unit, and it makes 240 units there. And because these joint costs are split off up here, they're still going to be allocated the same. Here we've got AC 92, which is going to sell for $45 at 320 pounds there. So when we plug that in then, we do actually make more money on both of these. So let's see here. So it says if neither V7 nor AC is processed further, should we produce them? I mean, I would say not, because we end up with overall a loss there. So if we can only do those intermediate products and don't have the option of refining them further, then I would say we probably shouldn't do it. Now, If we were to do just one, let's see here. So, looking at here. Oh, let me make sure I did my math right. So revenue per unit, is 200, did we say 240 pounds? Times $50 is $12,000. And oh, I forgot my further processing costs. Oh my goodness here. All right. So let's do this here, right? So that's our total revenue. Um, Let me look here. So I got my joint costs, further costs. All right. So we've got further processing costs of 2,000 and 1,500. So So comparing this, right, we actually make less money here than we did before, right? So up here we made 1,071 and down here, I'm gonna look here. All right, so what is our incremental? What is the difference between before and after, right? So here we're making actually, hold on, I should be doing this the other way around here. 32 minus the 23. Okay, so we're actually making $500 less here, right? And then here we're making $2,900 more. So the optimal combination would be to make the V7 and then not process that further because we actually the increase in revenue from the original 10,500 to the 12,000 doesn't make us enough money to cover the $2,000 in additional processing costs, but we do make quite a bit more over here, going from a loss to breaking even here. So our best combination then is going to end up being this profit here and then this profit down here. So a total then of making 3,971 if we did that combination, which looks ideal. Okay, so yeah, let me know if you have any questions on that. So in our last, or in the self-study problem that I had included for a medical center, they're walking through like what are the best ways to allocate out some of these different expenses. All right, so during the chapter, they walked through a couple of different methods for allocating costs out. So the direct method for allocating costs, let me just pull this up here really quick. Oops, hold on a second here. There we go. All right, so under the direct method, let me go back here. So you can take, say we have three different departments or areas that provide services to other departments. You could just come up with an allocation method that was separate for each one and assign the costs out to the different parts of your organization that were using them. So let's say we have an accounting department here, an HR department, and a maintenance department or IT department. And all three of these are providing services for three different parts of our company. We just determine, okay, well, the accounting department spends approximately a third of its time on each department. So we would take that and assign a third of it out to each of those client departments down below. The HR department, we might say like, oh, 2/3 of our hiring is for this department. So we'll sign that here. And then the rest gets split between the other two. And then the IT, maybe this department is super heavy on it. We'd put that there. 75% there and then split the rest over to the other two. And you could just allocate it out ratably, right? But the problem here is that, like, if we think about how a company actually works, right? These are operating departments down here, and these are service departments. We're not allocating any IT to our finance department that uses a bunch of accounting software and maybe has like a super expensive enterprise system. That doesn't really make sense, right? And the HR department hires people for the IT department and the finance department, and none of that's getting allocated either. So that's kind of a disadvantage of this direct method, because it doesn't properly assess the costs of the actual service departments. But it is, the advantage is that it's probably the easiest one for you to allocate those out from a math standpoint, right? And there is an example where they allocate out telecom and IT here in the text that I'm not going to walk through, because basically our examples that we've been doing in class have been pretty much using the direct method. Now, there's another method called the step down method, where one of the departments basically allocates some of it out to the operating divisions, but then also allocates some to the remaining service divisions. And then those service divisions, once they've been allocated for the first department, their total costs are like whatever it costs to run this HR department plus whatever costs from finance got charged to HR. That total cost then would get allocated out to the remaining like IT department. So HR would then take that total cost, put part to IT, and then part to the three operating divisions. And then last, the IT department would take the costs that were allocated to it partially from HR and its own costs and distribute those, and distribute those out. So either way, it gets done the same general process as far as taking total costs and allocating them all out to the operating divisions. But here you kind of include the other service departments that have not been distributed out yet, as you distribute these costs out to each subsequent department. And then there's a reciprocal method, which we are not going to cover here, and because it's too complex, but I'm going to talk about it, where they basically use linear algebra to do a complex calculation, and we could do it, but with the amount of time we have to allocate here and the fact that you guys are not going to actually be doing this, the reciprocal method is probably the most accurate method to make sure everybody gets their approximate equal parts and none of the departments goes uncharged for the other department's expenses. But the math is too complex for the scope of this class. So some companies do use this reciprocal method. Larger companies in particular that, have larger finance departments can do that. But if you think about all the things that go into the costing of each of these service departments in terms of salary, utilities, IT, and all of these other things, it gets to be very complex and you can spend a lot of money and time on this method. So, unless you have really good systems in place, the reciprocal method is not probably what you would end up using. The step down method is probably about as complex as most places would want to use. All right, so having just discussed that, looking back at our medical center example here, we've got a hospital, like a teaching hospital, kind of like Mayo, where they've got direct patient care going on, they've got research going on, they've also got teaching going on, and the faculty salaries are needing to be allocated across all of those. So what this problem talks about is they know how much time is or what percentage of time is allocated to each of these three activities for the faculty. So that probably makes the most sense to allocate out the faculty salaries to these different operating departments or operating areas within the company. So if we set up a financial statement here, let's do, which they did in the text, but I'm walking through this because they kind of skip steps in the text, and I want to just make sure everybody understands what the logic is that's being used here. They're going to allocate out all of these items also here. So if we look at this, so direct patient care here, we've got $297. I'm going to just put this for the hospital, right? In terms of direct research expenses, we'll put that to research, and then faculty salaries and benefits are $140. So we're going to split those out, okay? Um, And then down here, we've got medical school admissions and administration. That's pretty much just related to teaching here. So let's really quick get those. I'm going to put revenues here. Um, direct expenses here, we can call those out pretty clearly. And so that gets us to 380 million in direct expenses. Now, our next line item is income from the endowment. I'm going to kind of put this down here because that one you could argue, hey, people donate because they want the research to happen, or they want the education to happen, or they want this hospital to be available. So in terms of that endowment, unless they can identify like specifically what people are donating towards, that's sort of an amorphous one where they could be allocating that out based on a variety of things. So I'm going to just put a question mark on that one for now. Now, medical school tuition, that's 82 million. So that seems pretty clearly to be teaching revenue. And then we've got occupancy costs. So this is going to be our overhead here, right? We've got patient revenues, that's going to be for the hospital, and then sponsor research funding, that's going to be for research. Okay, so let's plug those in there. All right, so we've got that. And then we've got faculty salaries. So we know that we've got that 140 million, right? So I'm going to put here minus 140. And each of these, they've given us the percentages. So for teaching, I'm going to put 0.3 times that 140. I'm going to do 0.25 and 0.45. All right, so, and if we double check our numbers here, yes, that's 140. So, and that should be minuses. Okay, so with that, and then we've got the occupancy, which is the overhead, right? So we've got that 80 million that we need to distribute. Well, that doesn't seem like it makes sense to distribute that based on faculty time, but they do mention down here in the fine print that there's square footage known for the hospital, the school, and the labs. So if we say, hey, since these occupancy costs are utilities, maintenance, security, we'll base that on square footage. All right, so 250, 50, and 100. Gives us 400 total. So that's going to get us to and that does add up to 1. Okay. So those are the percentages for the square footage here. For um, the hospital, teaching, and research. Okay, because I did them in this order here. Okay, so in terms of that, then we're going to take 0.125 times the minus 80. And then 0.25. And then hospital 0.625. Double check our numbers there. Yes, we've got the minus 80. Okay, so then that's going to get us to, I'm going to put this, I'm just going to label this gross. So it's like before the endowment. And so now with the endowment in the textbook, let's see here. I mean, we could do that based on faculty salaries. That would be one way of doing it also. But it ends up, regardless of what we do, it's going to end up being sort of obligatory, like arbitrary, just picking some obligatory number. I mean, you could do it based on percentage of revenues. You could do it based on faculty salaries. Um, you could do it based on like, oh, who's doing the donations? Are the donations being done by like former students or former patients, or are they governmental, in which case maybe research. So there's a variety of ways that you can do that. Now, they ended up in the textbook doing it based on faculty salaries, which ends up getting you to these numbers. Oh my gosh. There we go. I can do Excel. All right. So that gets us to still very much in the negative on the hospital there. Let's see. Do I have the same numbers? Let's see. 370, 297. Oh, let me see here. Do I have these numbers right? That's minus 140. I've got different numbers here. What percentage do I have there? 0.25 and 0.45. Interesting. So I don't know. Hold on a second. Do I have those backwards? Oh, research is 45. Okay, sorry, I've got those wrong. There we go. Wrong percentages assigned in there. There we go. Okay, so so that gets us to we were losing money everywhere before the endowment, and now we're just losing money on the hospital here. Now, if we did this based on square footage here, right, then that would get us to because you could say, hey, they're a larger institution, therefore they maybe need more assistance. Well, then the hospital makes money and the other two lose money. So there's no win-wins here, right? Somebody's losing money and somebody's making money either way. Um, if you were going to rate it out based on, I mean, ultimately, right? We're losing 21 here and we've got 22. So we're overall breaking even. What if we do it based on percentage of revenues here? Let's do this. Try that one. See where that comes out. We apply that percentage here. Well, that gets us to 2 out of 3 making money, and this one with a small with a research on a small loss. So that gets us closer to. Um, any one of those methods you could pretty much argue because they're all arbitrary, right? Um, so there's a variety of ways you can do that. And again, like if you can argue which one you think is the best method, then again, that's acceptable, right? Unless there's a behavioral reason why one of them would be preferable to the other. Um, I would say in terms of this, basically any of these methods that you're using to allocate, ideally what you're choosing is that it is reflective of usage in some way, shape, or form. So I do think the percentage of time is the best way to do the faculty salaries, and the square footage that they used is the best for the occupancy, because the amount of space is basically, and lighting and stuff is going to generally drive what your occupancy costs are. So those all make sense to me to do those that way. And again, the endowment you could make a variety of arguments for. So we did here sort of a direct method, but with multiple different items having different allocations. And again, anytime you have an overhead allocation rate, all you're doing is taking the total amount of the overhead that you're allocating, dividing it by however many allocation units you have, and then assigning it out to each department. So like we talked about in the chapter 7. All right, so that kind of wraps up chapter 8. Let me know if you have any questions on those.